Hello, pre-calculus students. We haven't done a lesson in a while, so nice to talk to you all again. We're going to start section 6.1 on vectors. As I mentioned online, the last two sections we're going to cover here are 6.1 and 6.2 on vectors and applications of vectors. And then we'll be done with our new units for the school year. Okay, but these couple units are going to take a while, or a couple sections will take a while, especially 6.1. There's a lot of topics here. First, we're going to introduce vectors. That's what today's lesson is. A lot of new terminology and language and notation. And the math we're doing today isn't going to be hard at all. It's just a matter of getting the notation and the terminology down for vectors. And then we're going to do some problems with vectors using a lot of trigonometry, and then we're going to get to application problems at the end. All right, so vectors are a very important skill to know. Many things in life, the world around you can be represented by vectors. Forces, velocity, acceleration, motion, things like that can all be represented by vectors. So any of you who will take physics either in high school or in college someday, you will use vectors in physics very often. So it's good to have a foundation here in pre-calculus, so you know a little bit about vectors before you get to physics. And even if you don't ever take physics, like I said, knowing about vectors is good, just a good way to help explain the world around you. So for this, you're going to want to have your textbook handy because we're going to be referencing some things in 6.1. And I also just want to mention your textbook does a lot of explanations as well and shows some pictures beyond what I'm doing here. So I suggest you referencing your textbook while you're doing these problems. And if you need help or need further explanation, read through your textbook on 6.1. So anyways, we're going to talk about two-dimensional vectors here. You can get to three-dimensional vectors, and in like an upper-level math course or physics course, you may get to that. But for our class, we're just going to stick with two-dimensional vectors. So a vector V, okay, and in typing, vector is a bold arrow V. When we write it, we put a little arrow on top, as you see in a moment here, but they use a bold letter V. A vector V is an ordered pair of real numbers, which represents a directed arrow. So it's what's called a directed line segment. It's a line segment with a direction, okay? And a directed arrow from 2 points, starting with the initial point to the terminal point. Remember, on an angle, we had an initial side and a terminal side, the beginning and the end. Same thing with the vector, initial point and a terminal point. Okay, so here's what I mean. Let's say you have 2 points. We're going to put the initial point here at origin, and let's say you have a terminal point, somewhere else. Okay. This is a vector. Looks like that. Again, it's a line segment with a direction on it, a directed line segment or an arrow. It starts here and ends here. That is a vector. Okay. Vectors are represented by angle brackets. Okay, they don't have to be, but that's how your textbook does. So distinguish them from points, right? Points have parentheses like this. Vectors have angle brackets. So the component form of a vector AB, it's called that because you break it up into two components. The horizontal component and the vertical component. Just like in a point AB, A is the horizontal direction you move, B is the vertical direction. Same for the vector. So A is the horizontal component of the vector, and B is the vertical component. The standard representation of vector AB is the arrow from origin to the point AB. That's what I showed here. Okay, so let's say that AB is your terminal point and 0, 0 is your initial point. Then this is the vector AB. This is the vector AB, written with angle brackets to show it's a vector. So what does that mean? That means that you move A in the horizontal direction and move B in the vertical direction. Okay, so that is a standard representation. Okay. Now, here's the thing though. You could take this vector and you can move it horizontally or vertically. You can move it around the x-axis. As long as it has the same horizontal and vertical components, it is the same vector. Okay, so let me say that again. If I have the vector, for example, 2, 5, it goes to the right 2 and up 5. Okay, but it doesn't have to go from 0, 0 to 2, 5. It could be anywhere on the xy axis, have any initial and terminal point, as long as it goes 2 horizontally and 5 vertically. That is the same vector. Okay, we'll talk about that later. So a vector is determined by two things, the magnitude and the direction. The magnitude is the length of the arrow, so the length of that line segment is the magnitude, and the direction is the angle at which it's pointing. We'll get to that later. Okay, but this repeats what I said a moment ago. Any two arrows with the same magnitude pointing in the same direction represent the same vector. So one more time, I can take this vector and keep it the same length and pointing the same direction, move it horizontally, vertically around the xy axis. It is the same vector. It's the same vector. Okay, so how do I find a component form of a vector? We call it the head minus tail rule. Pretty simple. If I give you 2 points, the initial point and the terminal point, then it represents the vector v. And again, we put a little arrow on top. I do kind of a half arrow, just a line with the arrow at the top, not at the bottom. That's how I was taught to write it. Anyways, vector v, we do the change in x, comma, change in y. So it's x2 minus x1, comma, y2 minus y1. Okay. The reason it's called head minus tail is you're taking the head or the terminal minus the tail or initial, right? x2 minus x1, y2 minus y1. So it's always the terminal point minus the initial point, the head minus the tail. So if you're given 2 points, that's how we just describe a vector, find the component form. So let's do a practice with that. You're given 3 vectors here, u, v, and w. Okay, let's find the component form of each. Okay, so let's start with vector u. Well, let's see. It's going from the point 6, 4 to the point 1, 1. So let's start with the x. Change in x is going to be 1 minus 6, comma, and then change in y is going to be 1 minus 4. So what is that? That is -5, -3. All right. And look back at the vector, and let's count, what is it moving to go from here to here? It's moving to the left 5 and down 3. So that should make sense. It's moving -5 in the horizontal direction, -3 in the vertical direction. Left 5, down 3. That's the vector -5, -3. Okay. Let's do next the vector v. Same thing. Initial point, or I'm sorry, terminal point minus the initial point. All right. So we're going to do 4. Oh, sorry. So it goes from 4, -1 to -1, -4. All right. So we're going to do x2 minus x1. So -1 minus 4. And then y2 minus y1. So we're going to do -4 minus -1, or -4 plus 1. So what's that going to be? -5, -3. So notice u and v have the same horizontal and vertical components. So those are the same vector. One more time. U and v represent the same vector because they have the same horizontal and vertical components. And if you notice, if you take vector u and shift it to the left 2 and then shift it down, you would see it matches up with the same exact vector. Okay. And lastly, vector w, same thing. We're going to do head minus tail, or terminal point minus initial point. So it's going to be -2 minus -4, -2 plus 4 is your change in x, and 5 minus -3, or 5 plus 3 is your change in y. So that represents the vector 2, 8. And one more time, let's just check the horizontal and the vertical. It goes to the right 2 and up 8. So that represents the vector 2, 8. And let me just write down what I said a moment ago. Because vector u and vector v have the same horizontal and vertical components, u and v represent the same vector. Okay? So as I said, so far, the math isn't difficult, just knowing the terminology, what all these mean. Okay. So I want you to right now open your textbook, please, to page 449. I believe I had it the wrong number on your sheet. That was from the old textbook. But open to page 449. Look at exploration 1. They call it vector archery. Get it? It's a joke because it's arrow, so archery. Ha ha ha. Anyways, vector archery. So I want you to, when I'm done talking here, pause the video. I want you to try these 4 problems yourself using what we just talked about, the head minus tail rule. Try these 4 problems, and then when you're done, unpause it, and I'll go through the answers. Okay? So number 1, it gives you 2 points, initial point, terminal point. Find the vector. That's like the last example we did. Now, 2, 3, and 4, however, are a little different. It gives you an initial point and a vector. Find the terminal point. Same thing for 3 and 4, or similar, not the same, similar. It gives you 1 point and the vector. 1 point and the vector. Find the other point. Now notice 3, when it says PQ, that means that you're going from P to Q. So P is initial, Q is the terminal. In number 3, P is the initial point and you have the vector. Find Q, the terminal point. In 4, you're working backwards. You have the terminal point and the vector. Find the initial point. So just to be clear, in number 1, your answer should be a vector. In number 2, 3, and 4, your answer should be a point. Okay, so why don't you try those 4 right now? Pause the video, please. Try those 4 right now, and then when you're done, come back and I will go through the answers. Okay, so now let's talk about this here. Number 1, the vector is 5, comma 2. All right, hopefully everybody was able to see that without too much trouble. Okay, just do your head minus tail. And then for number 2 now, there's a couple ways you could have done this. One way is to set it up as an algebra problem, right? Because you know that you know the initial point, you want to find the terminal point. So let's call the terminal point xy. Then you know that x minus 3 should be the x coordinate of the vector, which is -3. And then y minus 5 should be the y component of the vector, which is 6. Well, solve for x and you get 0. Solve for y, you get 11. So there you go. The point is 0, 11. All right, now I put an XY axis here because I also want you to visualize this. I think if you visualize it, it'll also make sense. So we're starting at the point 3, 5. So everybody plot the point 3, comma 5. All right, and it represents the vector -3, 6. So let's, from this point, draw the vector -3, 6. So go to the left 3 and up 6. So go to left 1, 2, 3, up 1, 2, 3, 4, 5, 6. And there we go. That is that vector. Okay. Notice what point did I end up? I ended up at the point 0, 11. Okay. So by drawing these vectors, drawing the initial point and the vector on the XY axis, that might help you out. Okay. So 3 is exactly the same as 2 because you're given the initial point and the vector. So if you start at the point 4, -3, and you go to the right 2 and down 4, you're going to end up at the point 6, -7. Okay, and one more time, let's draw that here. Let's start at the point 4, -3, and then we're going to go to the right 2 and down 1, 2, 3, 4. All right, and where did you end up? You ended up at 6, -7. All right, now what about part 4? This is going backwards. It's saying that this is the terminal point. You want to find the initial point. So you want to work backwards from here. You were going to the right 2 and down 4. To go backwards, let's go to the left 2 and up 4. Okay, and I'm going to use my red pen just to distinguish. Go to the left 2 and up 1, 2, 3, 4. So I started from this point. All right, and then that's my vector. That's my vector to -4, to the right 2 and down 4. Okay, so what point did I start with? I started at the point 2, 1. Okay, or if you want to do what you did above, make it an algebra problem, but this time the subtraction goes the other way. So you could write it out. You could say that, let's see, 4 minus x equals 2, and then you could say -3 minus y equals -4. And then just use your algebra to solve for x. You'll get x equals 2, and you'll get that y equals 1. So there's your point 2, 1. Okay, so again, hopefully, if the math maybe is a little confusing, draw out the the picture. Draw the point and the vectors, and that should help you make sense of what's going on. Okay, and a little note here. Let me write below to kind of help you out here. If you start at the initial point and then you add the vector, you should end up with the terminal point. Okay, so that's basically what I did here, right? The initial point plus the vector is a terminal point. So just kind of realize that a vector tells you how to get from the initial point to the terminal point. That's one way to think about it. Okay, so now let's find the magnitude. So we said before that a vector is represented by two things, a magnitude and a direction angle. Okay, the magnitude of a vector is simply the length of the vector, okay? And it's denoted with vertical bars around the v. That's the magnitude. And this is pretty easy to get. You just do the Pythagorean theorem. It's just square root of a squared plus b squared, right? Because if you draw a vector, just think back to our first example. Where is that? Right. If I draw a vector here, I have a right triangle. This distance is a, this distance is b, so I can use Pythagorean theorem to find this distance there. Right. So the magnitude just comes from the Pythagorean theorem. All right. So find the here, for example, 2, it gives you 2 points PQ. Find the vector PQ and then the magnitude of it. Okay. So first thing you want to do is write the vector. Okay. Before you do the magnitude, let's do the vector. Same thing as before. Head minus tail. So -1 minus 5, and then 6 minus -2, or 6 plus 2. Okay, so that vector would be -6, comma 8. All right. Now, to do the magnitude of vector PQ, then we're going to do the square root of -6 squared plus 8 squared, which is the square root of 100, which is 10. So there we go. That vector has a magnitude of 10.